Hello everyone and welcome to my very first video online. So we're going to start off with victory prediction in chess, and this is going to be a machine learning algorithm that we're going to build from scratch. We're going to go through the entire process of data collection and extract, transform, load, and we're going to build the models, and we're going to deploy a model online. So I'm just going to quickly go over, okay, what's the goal of the project? Why did I pick this? I mean, obviously the very first thing is that I just enjoy chess, right? I like chess, but I also like programming, and there's a problem that I saw in terms of what people do online. And the problem is that when we have faster time controls, things like Blitz and Bullet, right? They're more popular now, even Rapid, right? They're more popular now because you can play online. You can play a very fast game, a very quick game, and it's not a huge time commitment, unlike committing to sitting down at a board for, you get 2 hours and your opponent gets 2 hours, and then after 2 hours of playing, you each get another hour. So in this case, I'm going to be focusing on faster time controls and trying to gauge who is winning based not just on the computer score. That's what we currently do. That's the current model that gets used in a lot of online streams, right? Who in the position between two different grandmasters, who is winning. But when it comes down to it, one of them might be winning because they took more time on the clock, they took more time to think, and so they have technically a positional advantage. They have an advantage that an engine can measure, but they don't have an advantage on the clock. And so as soon as they get low on the clock, they have to move faster, and they're more prone to making mistakes, and so you end up with a draw. So what I would like to do is look at, okay, things like rating difference and just normalize out the rating difference. If you have a grandmaster who has 1 minute versus a 1200 player who has 5 minutes, right, the grandmaster is still probably going to win, right? That's what I'm willing to bet. And once you normalize out the rating difference and the computer engine difference, how important is it that one person has more time on the clock? How does that contribute to a win? That's the real question here. I'm actually going to create a model that tries to predict what this is going to look like. So there are multiple factors to classify the game as white, black, or draw, right? And those are the factors. Who's going to win? Is it going to be white who wins? Is it going to be black who wins? Or is the result of the game going to be a draw? And that's three different classifications, right? The easiest part is the computer evaluation, right? I'm willing to bet that's the easiest part, right? I might be wrong. It might be far more complicated than that, and I might not be able to do this. We'll see. The more difficult part that I'm thinking is white rating versus black rating, and then you also have the rating difference. And those three components, how do those form to predict whether or not somebody is going to win the game? And then the hardest component that I think is going to be there is just the amount of time on the clock. White time on the clock versus the black time on the clock, how many seconds, minutes and seconds are left in the game, and then also the clock time difference. So how does that, as a minute is a difference between the two clock times, how big of a contributing factor is that to whether one person has an advantage over the other? My working theory is that the model will operate kind of like a naive Bayes classification. We might have 3 different classification things going on here. That's just a working theory right now. I'm sure that will change as we actually get into it. All I'm doing right now is just scoping out what I plan to do. The goal is that I'm actually just going to sit and program and go through these things and try to solve these problems, and you get to watch, right? And I would like to have some input. I want to leave a comment below, right? Like, subscribe to the videos. I want to get some interaction going as well, and just leave your thoughts below. So let's go to the next step, right? This is my proposed solution. How is this actually going to work? What are the steps that I'm going to use in order to actually solve the problem? I'm going to use data off of the lechess.org open database of games, right? database.lechess.org. They've got a massive source of all the games that are played on their website. They're one of the more popular websites. Obviously, they're not as big as chess.com, who boasts to be the biggest, but chess.com's data isn't just published in a flat file format that you can easily download. So I'm just going to acquire the lechess.org data, and we're going to use that as the basis for the model. We're going to download that. And we're going to have to extract the data from the BZ2 format that they've got up there. We're going to transform the data. My goal is we'll have to create a parser for the PGN format that they have. It will parse out the exact headers that we want to work with. We're going to pull out from that, we're going to extract the things that we really want, and we're going to create one line item for every single game. So each game will have its own record in the database, and it will have every single move in there as an analysis piece. So we'll be able to say, okay, on this move and this move and this move, and we'll be able to say, okay, here's where potentially the time difference, right, and the computer score really came into play. We're going to limit to only the games that have analysis. We're just going to stick with those games. It's going to be like maybe 5% of the database, 10% of the database, however much we get. That's what we're going to use. We're gonna get the headers from the file. So the who won, who lost, or who won, or was it a draw? What were the ratings of those individuals, rating difference, and then what were the times at every single step of the game. So what was the score, what was the computer score, and these are scores generated by Stockfish, and what was the time on the clock when that score was evaluated. And then we can see theoretically how the game progresses and be able to predict what the outcome of the game would be based off of how much time was used on each clock. Whew. And then finally, after we've got that data, we're going to load the JSON into a database format. We're going to split it out into multiple tables for multiple lookups, and I'm planning on putting it into an SQLite file. That's the current plan. We'll see where that goes. And of course, there's going to be lots of transformations going on at this throughout this entire process. The predictive model, like I said, I'm planning on using something akin to a naive Bayes probability, so hopefully it will be relatively fast in terms of the processing. We'll just have to see. My goal is to create the model tables based off of 30 to 40% of the data randomly sampled from the database, and then we'll test on the remainder of the games for how predictive the model actually is. And then we're going to rework the model until it's actually good, or hopefully at least it's positively correlated. I don't want to just get random predictions, right, that are correct 1/3 of the time. I could create a random generator to do that. So it's got to be right more than 1/3 of the time in order to actually be valuable. I would say half the time. If it's right half the time, that's good. It's really going to depend on the rating. The higher the rating of the person, the more predictive it's going to be. I'm guessing the more predictive it's going to be. The higher the rating of both parties. As soon as you get into lower ratings, obviously people make more mistakes, and so the analysis might just flip, and we'll just see where that goes and how to account for that. And then finally, the goal is to deploy a minimal REST API using Python's Flask, and then deploy that to the cloud using Heroku. So you could just theoretically ping the API with here's the analysis, here's the computer Stockfish generated analysis, here's the white rating, here's the black rating, here's the time on each of their clocks, and then it could theoretically spit out what the guess was, what the classification was for whether it would be white to win, black to win, or a draw. So there you go. That's the plan. We'll see if that actually happens. So At this point, the plan is in the next video, we're going to start looking at downloading the data and probably getting set up for processing, post-processing, what that entire flow should look like. The files are quite large, so we'll probably go through about 3 months of data, and we'll just take it as it goes. So thank you very much. See you in the next video. Have a great day.